Okay, let's dive right into this explainer. Welcome to a journey where the future isn't just a sci-fi fantasy, it's actively being built right now out of steel, glass, and, well, pure human ambition. Today, we're looking at Earth's absolute most insane megaprojects. At its core, what we're really exploring here is this primal, ongoing battle between our ingenuity and the planet's most unforgiving environments.
So let me ask you right off the bat, have you ever had dinner beneath the ocean? Sounds crazy, right? But people are actually doing exactly that. This is the Itha'a Undersea Restaurant over in the Maldives. It's this massive 175-ton glass structure that they built entirely on land and then meticulously lowered 16 feet down below the surface of the Indian Ocean. It's literally just a sheet of glass separating your dinner plate from the deep sea.
Or, hey, what about a moving research station on ice? Welcome to the totally bizarre reality of the Halley 6 base down in Antarctica. In a place where the ground beneath you is constantly cracking and shifting, solid ice has literally become the foundation for a futuristic, mobile fortress. And, understanding how we even attempt to build in these impossible conditions brings us to our first massive barrier, the crushing pressure of the sea.
Section 1. Conquering the Oceans.
Just look at the sheer ambition of the Shenzhen-Zhongshan link in China. Now, to let massive cargo ships pass underneath, the bridge towers to a staggering 251-foot sky clearance. That's the highest in the world. But then, and this is the crazy part, it pulls off a complete magic trick. The entire highway completely vanishes into a high-tech underwater tunnel running right along the seafloor, complete with patrol robots. It's a design that took a grueling 2-hour trip and slashed it down to just 30 minutes.
123 million. That is the exact number of cubic yards of sand engineers had to use to compress and build Dubai's Palm Jumeirah. Now, the wildest takeaway from this massive project, there isn't a single gram of concrete or steel holding those artificial island granges together. Zero. The whole shebang relies entirely on the natural compression of millions of tons of sand and rock battling it out against the ocean's currents.
Sometimes the obstacle isn't even the water itself. It's a conflict with the space around it. The brilliant problem-solving behind the Øresund Bridge really came down to one massive headache. A tall bridge would block planes trying to land at the nearby Copenhagen airport, but a low bridge would block the massive cargo ships on the water. So the solution? An amazing structural compromise. They built a bridge that literally dives right into the ocean, transforming into an underwater tunnel at a custom-built artificial island called Paberholm.
Consider these three very different structural conquests. First, you've got the Lake Pontchartrain Causeway in Louisiana. It's 24 miles long. The terrifying part is when you're sitting right in the middle and land completely disappears from your view. Then compare that to the Millau Viaduct, which anchors steel 1,100 feet high above a valley in France. But the most mind-bending one has got to be the Veluwe Aqueduct in the Netherlands. Imagine an underwater aqueduct where roughly 28,000 cars a day are driving underneath while hundreds of boats are sailing directly above their heads. It's totally wild.
Section 2. Touching the Sky.
Our next frontier takes us in the complete opposite direction, 2,717. That is the staggering height, in feet, of the Burj Khalifa in Dubai. I mean, it is so incomprehensibly tall that the temperature at the top can be 27 degrees Fahrenheit cooler than down on the ground. It's so high up that you can literally watch the sunset at the bottom, hop into a high-speed elevator to the top, and watch that exact same sunset a second time in a single afternoon.
But of course, building that high practically invites disaster from the wind. So what's the brilliant engineering solution here? The Y-shaped foundation. This specific structural design isn't just about looking cool. It actively breaks up dangerous, violent desert wind currents, significantly reducing their force, so the world's tallest building doesn't dangerously sway back and forth under all that pressure.
Now let's move over to a totally futuristic mechanical masterpiece over in Scotland, the Falkirk Wheel. First, tourist boats enter these massive gondolas. Next, a perfect 500-ton balance is achieved between the two sides, completely regardless of the load. Finally, a 5.5-minute rotation lifts the boats an incredible 79 feet into the air. And because of that perfect equilibrium, lifting 500 tons of weight uses only about 1.5 kilowatt hours. That is literally just the amount of electricity needed to boil 8 electric kettles. How crazy is that?
We're also totally redefining the skyscraper itself. Take a look at Raffles City in Chongqing, which is essentially a horizontal skyscraper. Engineers somehow managed to hoist a 12,000-ton sky bridge onto 4 820-foot towers. But the real stroke of genius?
It rests on sliding bearings, so it isn't rigidly fixed in place. It's actually allowed to gently slide back and forth, moving safely to survive the massive forces of heavy storms and earthquakes.
Section 3. Surviving extreme climates.
So we've conquered water and sky, but architecture also has to act as an impenetrable shield against the absolute harshest elements on Earth. And this brilliantly illustrates the two extreme ends of that spectrum. On one side, the Mariah Concert Hall uses 4,800 square feet of specialized mirrors to completely camouflage a world-class theater right in the middle of searing heat and violent Saudi Arabian sandstorms. Contrast that with the Svalbard Satellite Station. You have these massive, sci-fi-looking radar domes stationed right near the North Pole, capturing vital global space data in the middle of freezing, continuous polar darkness.
Sometimes, though, the extreme climate attacks right from the sky. Enter the Faraday cage, an enclosure used to basically block electromagnetic fields. This concept provides the life-saving magic behind the Margarita hut, which is perched dangerously at 15,100 feet up in the Alps. The entire structure is wrapped in a copper shell, and that turns the whole building into a giant Faraday cage, protecting the mountain climbers inside from brutal, direct alpine lightning strikes.
Remember that Antarctic research station we mentioned earlier? Well, here is exactly how it survives its climate. The ice shelf it sits on frequently cracks and shifts, so what do? First, they just lift up the massive hydraulic legs. Second, they literally tow the entire station on giant skis to a safer spot. And finally, they lock it right back down. Because this icy environment is so unbelievably harsh and isolated, the European Space Agency actually uses this exact station as an analog testing ground for future missions to Mars.
Section 4. Harnessing planetary power. All right, we've reached the absolute climax of our explainer. We are looking at megaprojects that are so impossibly massive, they don't merely exist on our planet, they actively alter it. And a big secret here is molten salt. It's a specialized heat storage material that allows solar plants to just keep generating electricity long after the sun goes down. The Jiquan Solar Power Facility uses this groundbreaking tech alongside 12,000 massive mirrors, essentially turning the arid Gobi Desert into a giant artificial sun, capturing and storing truly unimaginable levels of heat. And when it comes to harnessing the wind, the scale is equally staggering at the Rudong Offshore Wind Power Station. It's Asia's largest offshore wind station. The blades on these turbines are literally almost as long as a football field, and they anchor 4,500-ton foundations deep into the ocean floor. Why? So the station can swallow the kinetic violence of Yellow Sea super typhoons and convert all that fury into 2.4 billion kilowatt-hours annually. That's enough to power well over 1 million households. 42 billion. That's the number of tons of water currently held back by China's Three Gorge Dam, which is the largest hydroelectric dam in the entire world. To put that into perspective, storing this absolute mountain of water essentially acts as a gigantic battery for the grid. And that leads us to the ultimate, mind-blowing punchline of this entire explainer. We are actually slowing the rotation of the Earth. I'm serious. By concentrating 42 billion tons of water in one localized geographical area, scientists have confirmed that the Three Gorges Dam has actually altered Earth's moment of inertia. Human engineering has literally made our planet rotate just a tiny fraction of a second slower. No way, right? Which leaves us with this provocative final thought. As we build these massive sliding skyscrapers, towers that pierce the clouds, and dams that literally alter the spin of the globe, are we truly conquering nature? Or are we, finally, creating a new, necessary harmony to live within its extremes? It's definitely something to chew on the next time you marvel at human engineering. I really hope this explainer helped bring these ideas to life for you. Thanks for digging into the impossible with me.